whenever I grade these, because people aren't answering the question. This question is specifically asking for the max value, so make sure you give the max value. If this question was asking for the location, the X location, we do have that as well. So make sure you write it out this way. Welcome here to Cranky Calculus. I am going to go over extrema topics, specifically for this set of notes. It's going to be max and minimum values. Do not forget to like and subscribe. Also, make sure that you check out the free resources we have in the description here. We do have these set of notes for you, and we do have a set of keyed notes as well. Please check that out. And if you do, I will make more videos like this to help you out with your learning. So what we're going to do here is start to go through some important definitions for us. Such as absolute max, absolute min. Absolute max is the highest value in a function in its domain. Absolute min is the lowest function in its domain. That's really what all those fancy words are saying there. Relative maximum is the highest point in a little neighborhood of a function. You can have many relative maximums in a function, and the relative min is the lowest point in each neighborhood of your function. Big thing here is critical points for calculus. A lot of what we do is finding critical points. So critical number is a number essentially that where you set the derivative equal to 0 and you can find the critical point, or when the derivative is undefined. A lot of people forget about that undefined part. Relative extrema can only occur at critical numbers, and some vocab for you. It's specifically a critical point is a stationary point if the derivative is equal to 0. It's a singular point if the derivative is undefined. Many people forget about those singular points. So that being said, let's go ahead and do this example right over here off to the side. Let's go ahead and find our critical numbers of this. So the derivative of this function here is going to be 8/3 x to the negative 1/3 plus 5/3 x to the 2/3. Now we're going to want to set this equal to 0. When we do that, it's easiest if we factor this stuff out by using the GCF. Makes life so much easier. So this can be a little tricky for those of you that are new to find the GCF of exponents that are fractions. What you're going to do is you're going to pull out the smallest number here. So first off, I can totally pull out a 1/3 as a constant. That's pretty easy. But of my two terms, since negative 1/3 is the smaller of the two exponents, I'm going to pull that out. And then my first term here is going to leave me with an 8. And the second term is going to leave me with a 5x equals 0, and then you can go ahead and distribute this back into it, and you'll see that this does match up there. So that's a really good technique that you should know for calculus, is how to factor fractional exponents. So once we're here, I'm going to rewrite this derivative. It becomes a little bit more obvious how to find my critical point. So I have my numerator, which is 8 plus 5x, and I have my denominator here, which is going to be x to the 1/3. We're going to set this equal to 0. And if you notice right there, if I just set my numerator equal to 0, getting out there. If I set the numerator equal to 0, I'm going to get 8x plus 5 is equal to 0, which means that I'm going to get x equals negative 5/8. And we also have a critical point here. Actually, you know what? Critical point at, it says x, at x equals negative 5/8 and at x equals 0. How in the world do you get that x equals 0? Well, if we look at our denominator here, we're undefined when we set that equal to 0. So the derivative is undefined when the denominator is equal to 0. So make sure you check out your singular points as well as your stationary points. Moving on to some of the a picture here, which is going to help us represent maximums and minimums here. So you just have this graph here. It's on the domain from -2 to 4. The absolute max is the highest point, which is going to happen at the point 4, 21. The absolute minimum is the lowest point, which is going to occur at the point -2, -15. We do have a relative maximum at the point. You can see this right here is the highest in that neighborhood where I'm sketching right here in red, and that is going to be at the point 0.5. And the relative minimum is kind of think of like a valley. The lowest point right here is going to be 2, 1. Moving on to the next concept here, we do have the extreme value theorem. It is kind of a forgotten theorem, I think, of the big three theorems in calculus that we do for derivatives. We have IVT, we have EVT, we'll learn MVT eventually. For EVT, extreme value theorem, all it says that if a function is continuous, then we do have an absolute max and an absolute min that is on that function. A lot of times they'll ask questions instead of asking, is this continuous? They'll ask, does this have an absolute max? And it's up to you to be able to translate that question and say, oh, I need to prove that this function is continuous. So in order to find those absolute maximums, absolute mins values, we're going to use the candidates test. You can see the steps right here. What we want to do is we want to find our critical points. We need to know our endpoints, which are always given to us. And then we need to find the y values of the critical points, find the y values of the endpoints. And then of those values, the highest value is the max and the lowest value is the min. For this first problem right here, for this example, we're going to find the absolute maximum and minimum values of the function on the interval provided. So here we go. Let's go ahead and first find our critical points. And in order to do that, we're going to set this derivative equal to 0. So f prime of x is equal to, the derivative of x is just 1. And the derivative of this minus 2 cosine is going to be plus 2 sine of x. And we need to set that equal to 0. Just so you know, this function will not be undefined because there is no ratio here. Sine is a continuous function, so this derivative will never be undefined. So I only care about when the derivative is equal to 0. So when I were to solve for sine of x here, I'm going to subtract 1 from both sides. I'm going to get 2 sine of x is equal to negative 1. I will end up with sine of x is equal to negative 1/2. It's important that you know your trig values between 0 and 2 pi, because those are my endpoints right there. When does sine equal negative 1/2? This happens at x equals, that's going to happen in quadrants. So sine's positive in quadrant 1 and 2. So this is going to happen in quadrants 3 and 4. And we are in the pi over 6 family for the sine of x equaling 1/2. So we're going to be doing 7 pi over 6. And we're going to be doing 11 pi over 6. So now I'm going to do my candidates test. I'm going to make a chart. I'm going to include my endpoint, so I have 0 as an endpoint, and then I'm just going to go in order here. 7 pi over 6, and then I have 11 pi over 6, and then I have 2 pi. Those are my 4 candidates. 2 of the candidates are endpoints, 2 of the candidates are critical points. I'm going to plug this back into the original function. So when I plug in 0, I'm going to do 0 minus cosine of 0. Cosine of 0, by the way, is 1, so I'm actually going to end up with a value of a negative 2. All right. When I plug in a 7 pi over 6, I'm going to get 7 pi over 6 minus 2 cosine of 7 pi over 6. And that value is going to give me 7 pi over 6 minus, so when I plug in a pi over 6, it's actually, for cosine, it's going to be a positive root 3 over 2. So just a little bit of simplifying here. It's actually turned into a plus root 3. Okay. Kind of hard for me to know what the heck that value even is. But we just need to be able to compare everything. I think these values that we get will be fair enough for me to be able to compare. I'm going to get 11 pi over 6 minus 2 cosine of 11 pi over 6. That's going to give me 11 pi over 6 minus, this is usually root 3 over 2, so it's going to be just root 3. And if we plug in a 2 pi into the original, we're going to get 2 pi minus 2 cosine of 2 pi. Cosine of 2 pi is 1, so I'm going to get 2 pi minus 2. Yeah, I just checked. These values are not pretty. So this would be a question where we would have access to some type of Fourier function calculator here. So I'm just going to kind of help you out here. I'm going to type in this 7 pi over 6 into the original function. I get 7 pi over 6 plus root 3, and that is approximately 5.3 something. This 11 pi over 6, I plug that in, it's going to be about 4.02 something, and then 2 pi minus 2, it's a little bit easier because 2 pi is just going to be 3.14-ish times 2 minus 2. That's going to end up with 4.28. So from here, we can answer our question with these values. Again, this question is definitely a little bit more on the complex side, just because we would need the calculator to do a question like this, but you would need to show these steps. We're going to get the max value is, I'm going to give the exact value too because I prefer that on questions like this. The max value is 7 pi over 6 plus root 3. That occurs at x equals 7 pi over 6. And then we're going to get the minimum value as well. The minimum value, the smallest value in my table is going to be -2. And that occurs at x equals 0. I advise that you answer your questions this way for all candidates tests. What I'll get a lot, and I see a lot of whenever I grade these, is people aren't answering the question. This question is specifically asking for the max value, so make sure you give the max value. If this question was asking for the location, the x location, we do have that as well. So make sure you write it out this way. For all candidates questions, candidates test questions, they want to show the derivative is equal to 0. They want you to show the table, and they want you to actually answer the question. So that is how you get your points for any type of candidate test question. For this last problem here, we do have a piecewise function. I do real quickly want to check to see if this piecewise function is continuous. Reason being is because of the EVT that we talked about earlier, the function is not continuous, then we're going to have some issues here. So I want to quickly see if this does have an absolute max and absolute min. With that being said, if I were to substitute a 3 into the numerator there, I would get a solution of, it looks like a 3. So it looks like on the top, I'm going to get 3 right there. On the bottom here, if I were to plug in a 3, I would get 3 minus 0. So I'd also get a 3 if I just substitute in a 3 in each piece. So I'm good to go. I'm just going to erase that. But it's nice to know that, hey, this thing is continuous. So I do know it has an absolute max. It does have an absolute min. I do real quick want to rewrite this bottom one. I think if I were to just take out a root 4, would be just 2 root x minus 3. I think that's a little bit easier to work with, especially when we get to the derivative. Speaking of the derivative, let's go ahead and find that. Let's find the piecewise function's derivative. So the top piece here is going to be 2x minus 2. And that is what if x is less than 3. And then for this one right here, derivative of 3 is going to be 0 minus 2. I'm going to get 1/2. That's actually going to give me -1 over x minus 3. I'm a little quick on these derivatives because we're not focusing on finding these derivatives. We're focused on applying these things using the candidates test here. So since I'm going to do the candidates test, I do need to find out where g prime is equal to 0. It's important you state that g prime is equal to 0. For the top one right there, I'm going to do 2x minus 2 equals 0. And that's going to occur at x equals 1. And for that bottom piece, this bottom piece will actually never equal 0, but I am undefined at x equals 3, which happens to be the point where my piecewise function breaks off my two pieces. So when I do this candidates test, I want the endpoints, I want my critical points. Usually with the piecewise function, I'll always test the points in which the pieces break off because it's possible for it not to be differentiable. I think it's quicker to test the number rather than actually to go through and see if it is differentiable. So I do have my x values here. So since I'm testing from, you can see right there, from 0 to 12, I'm going to start at 0. I found a value at 1. We said that 3 were undefined, and then we're also going to make sure that we substitute in a 12. Make sure we substitute these in at the appropriate spot. So 0 is going to go in this top piece right there, which is going to give me a value of 0. 1 is also going to go this top piece right here because we're still less than 3. And that is going to give me an answer of -1. When I substitute in a 3, I'm going to get 9. Down here on this one, I'm going to get 3, which I did that earlier. I already kind of found that value. And then when I am to plug in a 12, I'm going to get 9 times 12 minus 12, 3 minus that. It's a lot of math. End up with a value of -3. So now I have all my values here. So I'm going to have an absolute max what is my absolute max? Like I can actually hear you. It is 3, and that happens at x equals 3, and my absolute min is -3, and that occurs at x equals 12. And that is going to wrap up our video here with extrema. Please like and subscribe for more content like this.